So here comes the intensity of an electromagnetic wave. So the energy crossing per unit area per unit time in a direction which is perpendicular to the direction of propagation of the wave is called the intensity of the wave. So can you observe it from the image? That is the energy which is crossing per unit area per unit time, that too in the direction of the propagation of a wave. It is the intensity of the wave. So intensity of the wave is nothing but energy per time divided by the total area. So energy by time can be represented as power. So power divided by area. So for an electromagnetic wave of average energy, density U is equal to I equal to UC. So we can write I equal to half epsilon naught E naught square C, which is equal to, that is for the electric field, epsilon naught E RMS square C. Likewise for the magnetic field, I equal to 1 by 2 mu naught into B naught square into C, that is 1 divided by mu naught B RMS square C. So this is the average energy density of the magnetic field and the electric field. So here comes the electromagnetic spectrum. So here you can see different colors now. So the orderly distribution of the electromagnetic waves in accordance with their wavelength or due to the frequency into a distant groups having widely differing properties. So each wavelength or frequency will have a different properties is called the electromagnetic spectrum. So for a particular range, it is radio waves, microwaves, IR radiation, that is infrared radiation, there is a visible light, ultrasonic, X-rays and gamma rays. So the violet color is the ultraviolet rays, which is harmful to us. So at different, for every wavelength and frequency, its properties will be differing. That is the electromagnetic spectrum. So here the main parts of the electromagnetic spectrum in the order of increasing wavelength from 10 power minus 2 Armstrong unit to 10 power 12 meter. That is from 10 power, that is the wavelength increasing from 10 power minus 2 Armstrong unit, or we can say it as in meter 10 power minus 12 meter to 10 power minus 6 meter, or the gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, microwaves and radio waves. So it is increasing. So you can see for radio waves how much it has given. Likewise for microwaves, for infrared waves, visible, for everything the wavelength is increased. Can you able to see it in the image? The wavelength of each light or rays is increasing. So the different parts of the EM spectrum differ in their methods of production and detection. So each rays detection and production are different from each other. So this is about the electromagnetic spectrum. So now we are going to do some problems on the basis of the concepts what we have seen before. Let us go into the problems. So the first problem is, an electromagnetic wave in a vacuum has the electric and magnetic field, that is E vector and B vector, which are always perpendicular to each other. So the magnetic fields, the electromagnetic waves are perpendicular to each other. The direction of the polarization is given by X vector and that of wave propagation by K vector. Then what will be the answer? They have given 4 options. Let us solve and find which option is the right one. So for this problem, the direction of polarization is given by the direction of electric field. Therefore, the direction of polarization is, in the question they have given it as x vector, which is parallel to the direction of the electric field, that is E. So, x vector is parallel to E vector. Likewise, the direction of propagation of electromagnetic waves, that is EM waves, is same as the vector E vector. E vector is nothing but the electric field into B vector. So, the direction of the propagation of the electromagnetic waves is same as the vector of the electric field into magnetic field. So, the direction of propagation of the electromagnetic they have given as K vector. So, which is parallel to the E vector into B vector. So, let us find the option where the option which has x vector is parallel to E vector, likewise K vector is parallel to E into B. So, let us find. So, where you can find this answer? In option B. So, option B is the right answer. So, x is, that is the polarization, direction of the polarization x is parallel to the electric field E, and the propagation of the EM waves K is parallel to the electric field and the magnetic field. So, B option is the right one. Let us move on to the next question. So, here for plane electromagnetic waves propagating in the Z direction. So, we have to find which one of the following combination gives the correct possible direction of the E vector and B vector, that is the electric field and the magnetic field respectively. So, let us find. So, for this question, let me solve option B. Okay, let me take the value, the combination of which is given in option B, that is minus 2i and minus 3j. So, this is the one set and another one is 3i minus 2i. 2j. So, let me do option B for you, but you have to calculate for every option and you have to find the correct answer. As I know B is the right answer, I simply solving to you. So, you can take this as E and B vector, E vector and B vector. Now, we can solve. So, 2i minus 3j into 3i minus 2j. So, when we solve, what you will get? 2, 3 minus 2 into 3 will get minus 6, minus 3 minus 2 will get plus 6. So, which will be 0. If it is 0, electric field and the magnetic field is 0, means we can say the electric field which is perpendicular to the magnetic field. Can you able to follow? Likewise, we are going to solve this in the matrix form. So, for that we can write it as I, J, K. Now, we can substitute the values over here. So, minus 2, minus 3, 3, and here it is 3, here it is minus 2. So, can you able to follow? For K there is no value, so we can put it 0. So, when we solve, what we will get? So, K is 0, no? So, we can take K outside and simply keep other values. Minus 2, 3, 3, minus 2. So, when we solve this in the matrix form, what you will get? You will get 13 K cap. So, from this we can say that the wave, electromagnetic wave propagating in the Z direction in positive Z direction. The electromagnetic wave propagates in positive Z direction. We have get the positive value over here. So I have derived for the option B, which is the right answer. Likewise, we have to solve it for other options also and to find the correct answer.